In this lesson, we're going to learn about order of operations. So first of all, what are operations? Operations are anything that you do with numbers. So you can combine them or take them away from each other or divide them, any of things like that. So you've learned many different operations. You've learned addition, subtraction, multiplication, division, exponents, and more recently, square roots. So when you come to a more complicated problem in math, say something like this one here, mathematicians have some rules about what order those operations are going to be used in. There's two ways you can remember what this order is. The first way is an acronym called BEDMAS, and the second way is by sort of remembering what level of operation you're doing first. So, first of all, I'll talk about the acronym. Both of these ways are perfectly good ways to remember. It just whatever fits better for you, whatever works better, then please use that one. So, with the acronym BEDMAS, what that stands for is brackets, and I'll get to what brackets are later. They're a little bit of an exception. Exponents and roots is what E stands for. D stands for division, M stands for multiplication, and A stands for addition, and S for subtraction. So the idea is that you are going to start at the top here and work your way down through these different operations. Now, there are a couple of sort of oddities to this system that you have to remember. First of all is, as you've probably noticed, exponents and roots are sort of combined. So E stands for exponents and roots. The second one is that with division and multiplication, as much as I say you follow this order, those two can be done in either order. You can do multiplication first, division first. It doesn't really matter. And similarly, between addition and subtraction, the same thing is true. So between addition and subtraction, you can do them in either order. So really, the order that you're going to end up doing things in is you're going to start with your brackets. So you do them first. Then second, you'll do your exponents. Then third, you'll do all of your division and multiplication together. And finally, the fourth step is to do all of the addition and subtraction. So if you like to remember exponents, that's a great way to remember the pattern. You just have to remember those little exceptions there. And so then the second way is by thinking about sort of what level of operations that we're using. And the important thing to remember here is that all of these are, or anything in one side is basically has an opposite in the other side. So I'll show you how this works. Early on, when you were in school and you learned about addition, that was the sort of the first thing you learned about. You'd count things up by ones. And so, for example, if you were going to add a number to 2, you would sort of count up by 1. So if we were to add 2 plus 4, we would start at the 2, and then we'd add up 1, 2, 3, and 4. Now, the reason why I say subtraction is the opposite to addition is that if we started at that answer there at 6, and we decided to go to subtract 4 from that, so instead of adding 4, we're subtracting 4, then basically you're going to end up 1, 2, 3, 4, back at the exact same spot that you started with. So that's why I say that addition and subtraction, they work in the same way. They count by ones, and the only difference is addition is increasing and subtraction is decreasing, but they really follow the same pattern. Multiplication and division have the same relationship. So in multiplication, you're basically talking about groups. So if I was to do groups of 2, and let's say I wanted 3 groups of 2, then I would start at 0, and I'd have one group of 2, 2 groups of 2, and 3 groups of 2. I should have used the red for that, but it doesn't really matter. It holds the same way. So that'll bring me up to 6. Now, if I had 6 and I wanted to divide it into 3 parts, then when I did do the division, then it would basically go back the opposite way, divide into 3 parts, and those parts would all be 2. So whether I'm doing 2 times 3 to get to 6, or 6 divided by 3 to get to 2, as you can see, it sort of works in the exact opposite direction. And finally, with exponents and roots, they're sort of the next level of multiplication. So if you remember with addition, I was always going up by ones. I was counting up by ones. With multiplications, I was sort of leaping by a same number. In this case, I was doing by 2s, but you could do it by 5s, by 9s, any number you wanted. You just sort of leap in the same amount every time. Well, exponents work a little bit differently because, for example, if I did the exponents starting at 2, if I did the exponents of 2, 2 to the square, 2 squared, 2 to the power of 2 is, I'm going to do 2 times 2, gives you to 4. But then if I do 2, so I'll just write that down, 2 to the power of 2. But then if I were to do 2 to the power of 3, I'd actually be doing 2 times 2, which is 4 again, and then times 2 jumps me all the way up here to 8. So if I did 2 to the power of 3, then it starts becoming sort of bigger jumps every time I get up, every time I go up. Now, we haven't done any sort of different types of roots. The only one we've done is square roots. So for the time being, I'm just going to ignore the fact that exponents go up to bigger numbers, and we'll just look at squares. So if I had have done 2 squared, then I would have gone up in the positive direction, 2 times 2. And then similarly, if I took 4 and I did the square root of it, so the square root of 4, I'd be going from 4, jumping back down to 2. So as you can see, a square and a square root are exactly the opposite direction, doing the exact same sort of thing. So that's what I'm just trying to show here. Similarly, if I squared the 3, I've erased my numbers here. If I squared the 3, it would have brought me up to 9, and then if I had a square root of the 9, it would bring me back to 3. And that pattern holds up for everything. So you just sort of have to remember, starting with the simplest operation, with addition and subtraction, that one's going to go in a positive direction, the other one's going to go in a sort of a smaller, so increasing and decreasing, I should say. Similarly, multiplication's the next more complex after addition and subtraction. So multiplication's going in an increasing fashion, division is decreasing, and finally the next more complicated type is exponents, and then the opposite, the one that makes it decrease, is the roots. So you can either remember it as an acronym or sort of this level going from the simplest to the more complex. And finally, you get to brackets. And both of these, I haven't really explained what brackets do. Brackets are really just a way for mathematicians to control what gets done. So if they don't want a certain part to be, or if they need a certain part to be done before sort of the BEDMAS rules would otherwise dictate, then they use those brackets to make sure that one section of that problem's done first, just so that everyone understands it's supposed to be done that same way. So let's see how this works out in practice. So again, I'm just going to use this expression that I showed you earlier, and we look at it first. So what's the first thing on our list? So we have brackets. No matter which one you're using here, we're starting with our brackets. So we do have brackets in this problem, so the first thing we need to deal with is this area here. Now, I'm going to draw that in blue because that's where we're changing our stuff into. So what's also important to know is whatever happens inside the bracket still has to apply to BEDMAS. So we need to figure out what is going on in this bracket before we can deal with that divided by the root of 36. Okay, so in the bracket, we don't have any more brackets inside the bracket, but we do have an exponent. So I'm going to make sure we do our exponent next. So we're still going to do 2 times, and we're still going to add that 12 on. But the next thing we need to do is we need to deal with this exponent. So basically, that 3 squared, so if we square 3, instead of it being 3 squared, we're going to write it as its answer. So 3 squared, 3 times 3 is 9. So now we've dealt with, we still haven't finished dealing with the brackets, but we've at least dealt with, we no longer have any exponents left in our bracket. So we're still working inside that bracket, but we've now dealt with our first part of the problem. So let's keep that bracket because we're still focusing totally on that area. And then we will, so this divided by the root of 36, we are not going to worry about that yet at all. That's still just outside of what we're dealing with. So the next thing after exponents, we don't have any exponents left, so now we go down to the next level, or we go down to the next level after exponents here. And we get to multiplication. So we do have multiplication happening right here, 2 times 9. So in that case, 2 times 9 is going to give us 18. And we've still got our plus 12 because that was, we were not dealing with that in that part there because that's our next step. So now we're still working on this bracket again because we haven't finished what's happening in that bracket yet. So let's keep that bracket there. And we still are not worrying what's going on outside the bracket. So this root of 36 is staying the exact same. And so now we have 18 plus 12. Well, 18 plus 12 is going to add up to 30. So now, as you can see, we've sort of figured out everything that's in that bracket. That bracket we don't need to worry about anymore. So we now, because we've got down that bracket to what that number actually is. It's the number 30. Okay, so now we can start thinking about what's outside of those brackets. So the next thing, so I'll leave our 30 here because the 30 isn't actually going to change right now because it's not the next important thing, because now when we were looking at this problem here, we have to go back to the beginning. So we don't have any brackets left, but we do have a root. So right here we have the root of 36. So we do need to address what is the root of 36. And our equals will stay the same. So if we do the square root of 36, 6 times 6 is 36, so the square root of 36 is 6. Now we're down to our very last operation that we can do because we've gotten rid of this bracket, then we got rid of our square root. So now the next thing we have to deal with is division and multiplication. So we do have division right here. So actually, I won't even bother writing this here because 30 divided by 6, we can do the answer to that just using simple mathematics, is 5. So 30 divided by 6 is 5. So really, this quite complicated looking thing here, all it was really saying was 30 divided by 6. We just didn't know that that was equal to 30, and we had to do a little bit of work to find out that that equals to 6. That's a bit more obvious, but really that's what our entire problem was showing us. So if you try to keep using this process, starting with any of your brackets, then going on to your exponents and your roots, then on to your division and multiplication, and finally down to your addition and subtraction, and just keep following that pattern, then you can solve all sorts of different complicated looking math problems. I hope this helps.